This is an audio-visual presentation on construction. Now let's first look at angles. An angle is formed when two straight lines intersect at a point. An angle is formed when two straight lines intersect at a point. Now considering the figure as shown, AC is a straight line. AB is also a straight line. Line AC and line AB intersect at the point A. Now where the two lines, that is line AC and line AB, intersect, an angle is formed. And so the angle formed at the point A, that is the point of intersection of the lines AC and AB. Now the angle formed at the point of intersection is theta. Now we look at bisection of angles. When we talk about bisection of angles, we mean dividing angles into two equal sizes. We mean dividing angles into two equal sizes. Now we have a compass. A compass is a mathematical instrument. This is a mathematical instrument that you are going to use in constructing our circles and describing our arc. Now a compass has two ends. We have the pointed end and we have the end with the pencil. So if we are constructing a circle or describing an arc, you will stand with the point A of the compass, while the end with the pencil, that is the point B, describes the arc or the circle. I repeat, when you want to describe an arc or you want to construct a circle, you stand with the point A at the point around which you want to describe your circle or your arc, while the end with the pencil describes the circle or the arc itself. Now, when it comes to describing of the arc, you stand with the point A of the compass at the point around which you want to describe your arc or you want to draw your circle, while the end with the pencil describes the arc as shown. While the end with the pencil describes the arc as shown. So bisection of an angle. Now, AC is a straight line and AB is also a straight line. Line AC and line AB intersect at the point A. And where these two lines intersect, that is where the line AC and the line AB intersect, an angle is formed. So because the line AC and the line AB intersect at the point A, it means that the angle formed is at A. Now how do we bisect this angle? How do we divide this angle? How do we divide the angle at A into two? Now you stand at the point A with the help of your compass. You open to a reasonable radius and describe an arc as shown. Where the arc cuts the line AC, you name it E. And where the arc cuts the line AB, you name it F. Now you stand at point F, open to a reasonable radius. Or you can also use the same radius that you use in describing the arc. Now you stand at F and describe an arc as shown. You stand at F and you describe an arc as shown. Now you stand at E with the same radius that you used in describing this first arc. Stand at E and describe another arc as shown. Where the two arcs intersect, name it point D. Now we draw a straight line from A, passing through the intersection of the arc. And we have our straight line. That is the straight line drawn from A, passing through the point of intersection of the arc. That is D. Now we have two angles now. We have angle CAB and angle DAB. Now angle CAD is equal to angle DAB because we have bisected the angle CAB into two equal angles. So angle CAD is equal to angle DAB. That is our angle CAD is equal to angle DAB. Construction of an angle of 60 degrees and 120 degrees. Now let's look at how we can construct an angle of 60 degrees and 120 degrees. Now you draw your straight line. So we have our straight line drawn with the help of our ruler. So we have the straight line AB drawn. Now you indicate a point on the straight line where you want to construct the angle. I repeat, after drawing the straight line AB with the help of your ruler, you indicate a point on the straight line where you want to construct your angle. So assuming we've indicated this point, that is point C. How do we construct the 60 degrees angle? How do we construct the 60 degrees angle? How do we construct the 60 degrees angle? You stand at point C. Open your compass to a reasonable radius and describe an arc as shown. Name the ends D and E as shown. That is the point of intersection where the arc touches the line AB. You name it point D and point E as shown. Now, with the same radius that you use in describing this arc, stand at E with the same radius and describe an arc on the first arc as shown, and name the point of intersection F. With that same radius, stand at F and describe another arc and name the point of intersection G. Now draw a straight line from C passing through F as shown. A straight line from C passing through F as shown. The angle is now a 60 degrees angle. That is angle HCB. So that is how we construct a 60 degrees angle at a point. Now you also draw a straight line from C passing through G. So that is a straight line drawn from C passing through G. And the angle is 120 degrees. That is angle ICB. That is the whole of this angle. Is a 120 degrees angle. Is a 120 degrees angle. That is angle ICB. Is 120 degrees. So in general, that is how we construct an angle of 60 degrees and an angle of 120 degrees about a point. Now, construction of an angle of 90 degrees, 45 degrees, and 135 degrees. Now, we draw our straight line AB. Locate a point on the line, let's say C. Stand at C and open to a reasonable radius and describe the arc as shown. Name the point of intersection of the arc and the straight line AB, D, and E as shown. Now, you stand at E. Open to a reasonable radius above the line AB and describe an arc as shown. That is, you stand at E and open to a reasonable radius and describe your arc with the help of the compass. Now, with the same reasonable radius, stand at D and describe another arc. Where the two arcs meet, you draw a straight line from C passing through the two arcs, passing through the intersection of the arc as shown. This angle is a 90 degrees angle. This angle is a 90 degrees angle. And the angle at C, that is this angle, is also a 90 degrees angle because the angle that a straight line makes at a point is 180 degrees. So this angle is 90 and this angle is 90. So that is how we construct the 90 degrees angle. That is how we construct the 90 degrees angle. Now, how do we construct the 45 degrees angle? We now know how to bisect an angle. We now know how to bisect an angle. That is how we can divide an angle into two equal angles. Now, we have our point D and our point G. So you stand at G open to a reasonable radius and describe an arc as shown. With that same reasonable radius, stand at D and describe another arc. Where the two arcs meet, draw a straight line from C passing through the intersection of the arc as shown. That is, you draw a straight line from C passing through the intersection of the two arcs as shown. So we have the 45 degrees angle. The angle here is 45 degrees and the angle here is also 45 degrees because the total angle here is 90 degrees. So that is how we bisect an angle. So we have bisected the 90 degrees angle in order to get a 45 degrees angle. So if you want to construct a 45 degrees angle, it means that after constructing a 90 degrees angle, you bisect the 90 degrees angle and you will have the 45 degrees angle. Now take note that this angle is 90 and this angle here is 45 degrees. When we add 45 degrees to 90 degrees, the angle is 135 degrees. That means that the angle from E to this point is 135 degrees. So that is how we construct a 135 degrees angle. That is after constructing the 90 degrees angle. After constructing the 90 degrees angle, you now bisect the angle 90 to get 45. When you add the angle 45 to the angle 90, you get a 135 degrees angle. So that is how we construct the 135 degrees angle in general at a point. Now construction of an angle of 75 degrees. Now we know how to construct the 90 degrees angle. How do we construct the 75 degrees angle? Now take note that before we drew a line from C passing through the point of intersection, we first describe the arc as shown. That is the arc DE. Now this arc was described with a reasonable radius. With that same radius that you use in describing this arc, stand at point E and describe another arc on that first arc as shown. That is, with the same radius that you use in describing the first arc, stand at point E and describe an arc. Draw a straight line from C passing through the intersection of the two arcs, and that's the straight line drawn. Name this point of intersection F and name this point G. Now take note that this is a 60 degrees angle because that is how we construct a 60 degrees angle, if you remember. Now this total angle here is 90 degrees and the angle we have here is 60. That means that the angle we have in between G and F is 30 degrees. Now when we bisect the angle 30 degrees, we have 15 degrees each. So we stand at point G and describe an arc as shown by means of a reasonable radius. You stand at point G, open to a reasonable radius and describe this arc as shown. With that same reasonable radius, stand at point F and describe another arc as shown. Stand at point F and describe another arc as shown. You now draw a straight line from C passing through the intersection of the arc. That's the straight line drawn from C passing through the intersection of the arc as shown. Now the angle GCB is a 75 degrees angle as shown by the help of the arrow. That is the 75 degrees angle. So in general, that is how we construct a 75 degrees angle. That is, you first construct your 90 degrees angle. After constructing the 90 degrees angle, you now construct a 60 degrees angle and you bisect the 30 degrees angle and have 15 degrees angle each. When you add that 15 degrees angle to the 60 degrees angle, you have the 75 degrees angle. That is how we construct the angle of 75 degrees. Now bisection of a line segment. When we talk about bisecting of a line segment means that we are to divide the line into two equal lengths. Now, considering the straight line drawn, we have point AB on the line. So AB is a straight line. When we talk about bisecting of the line AB, it means that we are to divide the line AB into two equal lengths. Now, how do we bisect the line AB? You stand at point A with the help of your compass, open to more than half the distance between A and B. I repeat, when you are bisecting the line AB, you stand at point A with the help of your compass, open to a reasonable radius more than half the distance between A and B, and describe an arc above the line AB and below the line AB as shown. I repeat, you stand at A, open to a radius greater than half the distance between A and B, and describe an arc above the line AB and below the line AB. Now, with the same radius that you use in describing the arc above the line AB and below the line AB as shown, stand at point B with the same radius and describe another arc above the line AB and below the line AB as shown. Name the point of intersection of the arcs C and D. Now, we draw a straight line passing through the point of intersection of the arc above the line AB and below the line AB as shown. So we draw a straight line from C to D. Now that is the straight line drawn. The distance from A to E is equal to the distance from E to B. That means that we have bisected the line AB into two equal lengths. That is, the length of AE is now equal to the length of EB. That is how we bisect a line segment. Now, constructing the perpendicular to a given line from a given point outside the line. How do we construct the perpendicular to a given line from a given point outside the line? Now, the point can be above or below the line. So indicate your point either above or below the line. Now, assuming we have our point at C, we want to construct a perpendicular from the point C to this straight line. So after indicating the point, you stand at the point C. With the help of your compass. Describe two arcs on the straight line as shown. I repeat, you stand at the point C and you describe two arcs on the straight line as shown. Name the point of intersection A and B as shown. Now, you stand at A, open to a reasonable radius, and describe an arc below the line AB as shown. With the same radius that you use in describing this arc, stand at point B and describe another arc as shown. Where the two arcs meet below the line AB, name it point D. We are now going to draw a straight line from C to pass through D, and that is the straight line drawn. So you draw a straight line from C to pass through D. This straight line drawn from C passing through D is perpendicular to the line AB. This straight line drawn from C passing through D is now perpendicular to the line AB. So that is how we construct the perpendicular to a given line from a given point outside the line. Now let's proceed. Construction of a line parallel to a given line at a given distance. How do we construct a line parallel to a given line at a given distance? When we talk of parallel lines, we mean lines that do not meet at any point. So how do we construct a line parallel to a given line at a given distance? Now you first draw your line AB. So AB are 2 points on the straight line. So we have point A, we have point B. At a given distance, that means that the distance from the line AB to the parallel line you are going to draw will be given. So now, you stand at point A, you open to a reasonable radius with the help of your compass and describe an arc as shown. So you describe the arc on the left of A and on the right of A. You also describe an arc on the left of B and the right of B. Now you stand at this point, open to a reasonable radius and describe an arc. You stand at this point, open to a reasonable radius and also describe an arc. And you have the point of intersection of the two arcs. Now do the same thing at B. That you stand at this point, you describe an arc. You stand at this point with the same radius, you describe an arc. Now, given the distance, you stand at A, either A or B first. You can stand at A, measure the distance given with the help of your compass on the ruler. Stand at A and describe the arc as shown. That is, after standing at A to describe the arc, you also stand at B with that same distance given and describe another arc as shown. I repeat, the given distance, the distance will be given. So when you stand at A, open to that distance given and describe the arc above the line AB. With that same distance, stand at B and describe the arc as shown. You now draw a straight line from A, passing through the intersection of the first arc to the second arc. You do the same thing at B. So we now draw a straight line from A, passing through the intersection of the two arcs we first described. So we draw a straight line from A, passing through the arc. We draw a straight line also from B, passing through the arc as shown. So these are the straight lines drawn. We draw these two straight lines. We draw these two straight lines. Now, after drawing the straight lines, you draw a straight line from this point to this point, and you name the point of intersection PQ. Now, the line PQ is now parallel to the line AB. The line PQ is now parallel to the line AB. Now, I repeat, construction of a line parallel to a given line at a given distance. What I said is you draw the line. So you have your point AB on the line. Now AB is a straight line. So stand at A, open your compass to a reasonable radius and describe arcs on the left of A, on the right of A, on the left of B, on the right of B. Now after describing the arc, you also stand at this point, describe an arc, stand at this point and describe an arc with the same radius above the line AB, and you do the same thing at B. You do the same thing at B. Now when the distance is given, you measure the distance with the help of your compass on the ruler. Stand at A and describe another arc above the intersection of the first arc. So whatever you do at the point A, you do the same thing at the point B. With the same given distance, you also describe the arc as shown. You now draw a straight line from A and B, passing through the arcs to touch the arc drawn, and that is the straight line we have. Now you draw a straight line from this point to this point as shown. The line PQ is now parallel to the line AB. That means that these two lines will never meet. Line AB and line PQ will never meet because they are parallel lines. So that is how we construct a line parallel to a given line at a given distance. Now we have construction of triangles. To be able to draw a triangle, we must be given 1, the length of all the 3 sides, because you know that a triangle is a closed plane figure with 3 sides. So to be able to draw a triangle, we must be given 1, the length of all the 3 sides, or 2, the length of 2 sides and an angle between any 2 sides, or 3, the sides of any 2 angles and the length of 1 side. So to be able to draw a triangle, we must be given either the condition in 1, or the condition in 2, or the condition in 3. Now example, construct a triangle PQR where PQ equals 8 centimeters, PR equals 9 centimeters, and QR equals 7 centimeters. Measure the angles of the three vertices. Now, this is an example of construction of a triangle. Here we are given three sides. We are given all the three sides. That is, we are given the side PQ to be 8 centimeters. We are given the side PR to be 9 centimeters. And we are also given the side QR to be 7 centimeters. Now let's see how best we can construct this triangle with the three given sides. Now from the question, we were given the length PQ to be 8. So you draw the line PQ 8 centimeters with the help of your ruler. You draw the line PQ 8 centimeters. Now line PR equals 9 centimeters. That means that the distance from P to R equals 9 centimeters, and R is the third vertex of the triangle. So we measure the distance 9 centimeters with the help of our compass on the ruler, and we stand at point P. We stand at point P with a measured radius of 9 centimeters. We stand at point P and describe the arc as shown. We describe the arc as shown. We describe the arc as shown. Now, the distance from Q to R equals 7 centimeters. The distance from Q to R has been given to be 7 centimeters. So we measure the distance of 7 centimeters with the help of our compass on the ruler and stand at Q and describe an arc as shown. Where the two arcs meet, we name it R. PQR is a triangle, so we need to draw a straight line from P to R as shown. That is the straight line drawn from P to R, and the distance is 9 centimeters because we were given PR to be 9 centimeters from the question. We also draw a straight line from Q to R, and that is the straight line drawn from Q to R, and the distance is 7 centimeters, also given in the question. So we now have our triangle PQR with PQ 8 centimeters, QR 7 centimeters, and RP 9 centimeters. So that is how we construct a triangle when we are given three sides. Now example, construct a triangle ABC such that angle BAC equals 60 degrees. Length AB equals 8.5 centimeters and length AC equals 7 centimeters. Measure the distance BC. Now with this question, we can see that we are given two sides and an angle. The two sides given are side AB, that is 8.5 centimeters, and side AC, that is 7 centimeters. And we are given the angle, that is angle BAC, to be 60 degrees. Angle BAC, that means that the angle is at A. The angle is at A. So the angle at A is 60 degrees. Now let's see how best we can construct this triangle given the two sides and an angle. Now from the question, we were given angle BAC to be 60 degrees. We were given angle, the length AB to be 8.5 centimeters, and we were given the length AC to be 7 centimeters. So we can see that we are given angle BAC to be 60 degrees. We are given the length AB to be 8.5 centimeters, and we are also given the length AC to be 7 centimeters. So the first thing you do is to draw the line AB. Now we draw the line AB with the help of our ruler and our pencil. So we have the line AB drawn. The length of AB is 8.5 centimeters from the question. Now angle BAC equals 60 degrees. That's the angle at A equals 60 degrees. Now you know how to construct a 60 degrees angle. You stand at point A, you open to a reasonable radius and describe an arc as shown. You describe an arc as shown with the help of your compass. You stand at point A and describe an arc as shown. Now with the same radius, stand at this point and describe another arc. That is the arc as shown. We now draw a straight line from A passing through the intersection of the two arcs, and that's the straight line drawn. The straight line drawn is line AC. Because the triangle is AB, that means that the last vertex is C. So we have our C here. Now, from the question, the distance from A to C is equal to 7 centimeters. So, before you describe this arc as C, you have to measure 7 centimeters with the help of your compass on the ruler, and stand at A and describe the arc at C, and describe the arc at C. So the distance from A to C is equal to 7 centimeters given from the question. Now we know that ABC is a triangle. That means that we have to join the points B and C. And so we draw a straight line from B to C as shown. We draw a straight line from B to C as shown. Now from the question, we were asked to measure the distance BC. Now after measuring the distance BC, the distance gave us 7.9 centimeters. The distance gave us 7.9 centimeters. So that is how we construct a triangle when you are given two sides and an angle. That is how we construct a triangle when you are given two sides and an angle. Now example, construct a triangle PQR such that PQ equals 9 centimeters. Angle QPR equals 60 degrees and angle PQR equals 45 degrees. Measure PR and QR. That is the length of PR and the length of QR. Now, with this question, we are given two angles and a side. The two angles we are given are angle QPR, 60 degrees, that's the angle at P, and angle PQR equals 45 degrees, that's the angle at Q. And we are given only one side, and that is the length PQ to be 9 centimeters. Now let's see how best we can construct this triangle when you are given two angles and only one side. Now, from the question, you were given the distance PQ to be 9 centimeters. So with the help of our ruler and the pencil, we draw the line PQ, a straight line from P to Q. The distance is 9 centimeters. From the question, the angle at P, that is angle QPR, equals 60 degrees. So the angle at P is equal to 60. And you know how to construct a 60 degrees angle. And that is what we have done. So you stand at point P, you open to a reasonable radius and describe the first arc. With that same radius, stand at this point and describe the second arc. Now, the angle PQR equals 45 degrees. That is the angle at Q equals 45. So before we can construct the angle of 45, we first have to construct the 90 degrees angle. And since you now know how to construct a 90 degrees angle, that is the angle we have constructed as shown. So this is our 90 degrees angle. Now you stand at point T, open to a reasonable radius and describe an arc. Stand at point S with the same reasonable radius and describe another arc. And these two arcs will intersect. Now draw a straight line from P passing through this intersection of the arcs. I repeat, draw a straight line from P passing through the intersection of these two arcs. You also draw a straight line from Q passing through the intersection of these two arcs as shown. Now where the two lines drawn from Q and P meet, name the point of intersection R. Now from the question, you have to measure the distance PR. Now when we measure the distance PR, we have 6.6 centimeters. And when we measure the distance QR, we have 8.1 centimeters. So that is how we construct a triangle. That is how we construct a triangle when we are given two angles and only a side. Now we have construction of a quadrilateral. We have construction of a quadrilateral. Example, construct the rectangle PQR, where PQ equals 6 centimeters and QR equals 5 centimeters. Now when we talk of a quadrilateral is a four-sided figure. I repeat, a quadrilateral is a four-sided figure. A quadrilateral is a four-sided figure. A quadrilateral is a four-sided figure. Now, from the example, we are asked to construct the rectangle PQRS, where PQ equals 6 centimeters and QR equals 5 centimeters. So the distance from P to Q equals 6 centimeters. So we draw the straight line PQ. So we have our point P and our point Q. The distance from P to Q is 6 centimeters. Now you stand at point P, open to a reasonable radius, and describe the arc on the left of P and on the right of P. You do the same thing at Q. Describe an arc on the left of Q and then on the right of Q. Now you stand at this point, open to a radius above the line PQ, and describe an arc. You stand at this point and also describe an arc. You have the two arcs intersecting at the point. You do the same thing at Q. That you stand at this point, you describe an arc. With that same radius, you stand at this point, you describe another arc. Now, we are given the distance from P to Q to be 6 centimeters. So we have the distance from P to Q to be 6 centimeters. Now the distance from Q to R is 5 centimeters. Now this is a rectangle PQRS. So we have PQRS. That means that we have our R here. Now we know that the distance from Q to R is 5 centimeters. So you measure 5 centimeters on the ruler with the help of your compass. You stand at Q and describe an arc with that measured radius 5 centimeters. Stand at Q and describe your arc as shown. You describe the same arc standing at P, also as shown. You now draw a straight line from Q, passing through the intersection of the first arc you drew. You also draw a straight line from P, passing through the intersection of the first arc you drew to the second arc. And that is what we see. We name the point of intersection of the line and the arc S. And we name the point of intersection of the line and the arc R. Now we draw a straight line from S to R. We draw a straight line from S to R. So now we have P, Q, R, S. We have P, Q, R, S. And that is a rectangle. So that is how we construct the rectangle. That is how we construct a rectangle when you are given two sides. Construction of a parallelogram. Construction of a parallelogram. Now let's take a look at this question. With the aid of a pair of compasses and a ruler, construct a parallelogram ABCD such that AB equals 7 centimeters, angle BAC equals 60 degrees, and angle ABC equals 75 degrees. Measure the length BC. Now let's see how best we can construct this parallelogram. Now you are given the length AB to be 7 centimeters. Angle BAC equals 60 degrees. That is the angle at A. We consider the middle letter. So the angle is at A. The angle at A is 60 degrees. Now angle ABC equals 75 degrees. The middle letter is B. So the angle 75 degrees is at the point B. Now you first draw the line AB, that is 7 centimeters, with the help of your ruler and the pencil. You draw the line AB, 7 centimeters. The angle at A is 60 degrees. So you construct a 60 degrees angle at A. And you know how to construct a 60 degrees angle now. That is, you stand at point A, you open to a reasonable radius and describe the first arc. With that same reasonable radius, stand at this point and describe another arc. A line from A through the intersection of the arc will give you the 60 degrees angle as shown. Now the angle at B is 75 degrees, and you know that before you can construct a 75 degrees, you need your 90 degrees. You need your 90 degrees and your 60 degrees angle. You know how to construct the 90 degrees angle. That is, after describing the arc as shown, you stand on this point with the help of a compass, open to a reasonable radius and describe an arc. Stand at this point with the same radius and describe another arc. So we are now going to draw a line from B passing through the intersection of the two arcs. And we are also going to draw a straight line from A passing through the intersection of these two arcs. Now, when we draw the straight line from A passing through the intersection of this arc, that is what we have. That is the straight line we have. And we also draw a line from B passing through the intersection of these two arcs. Now, with the same radius that you use in describing this arc, stand at this point and describe another arc on the first arc. Take note that the angle made here, that is when you draw a line from B through the intersection of this arc, the angle here will be 60 degrees angle. That means that the angle here is 30 degrees, because 60 plus 30 will give us 90. Now we stand at this point, open to a reasonable radius and describe the arc as shown. With that same radius, stand at this point and describe another arc as shown. So we are going to draw a line from B passing through the intersection of these two arcs, and that's the straight line as shown. The angle is a 75 degrees angle. This angle is a 75 degrees angle as shown with the help of the arrow. Now we have A, B, C. Take note that we have to construct the parallelogram A, B, C, D. That means that we have our D somewhere here. Now, how do we locate the point D? Now, let me show you. The distance from A to B, because it's a parallelogram, AB and CD are parallel sides. The distance from A to B is equal to the distance from C to D. So if the distance from A to B has been given to be 7 from the question, then we measure the same 7 centimeters with the help of our compass on the ruler, and we stand at the point C and describe an arc as shown. That is, with a radius of 7 centimeters measured with your compass on the ruler, you stand at point C and describe the arc as shown. Now, the distance from B to C, we have to measure the distance from B to C, and after measuring, we had 8.6 centimeters. So the distance from B to C is the same distance from A to the point D. So we measure the distance of 8.6 with the help of our compass on the ruler, and we stand at A and describe an arc as shown. The two arcs intersect. The two arcs intersect. You name the point of intersection D. Name the point of intersection D. We now draw a straight line from C to D as shown. Then we also draw a straight line from A to D also as shown. Now ABCD is a parallelogram. ABCD is a parallelogram. So that is how we construct a parallelogram. That is how we construct a parallelogram. The locus of point equidistant from a fixed point. The locus of point equidistant from a fixed point. If the point P moves in a plane so that its distance from a fixed point O, its distance from a fixed point, our concentration is from a fixed point O, is always constant. From a fixed point O is always constant, then the locus described by P is a circle. Now, example, a point P moves in a plane so that its distance from a fixed point is 3 centimeters. Construct the locus. So the locus is just a circle with a radius of 3 centimeters. That means that you measure 3 centimeters with the help of your compass. So with center O, with a radius 3 centimeters, you describe the arc as shown. You describe the circle as shown. I repeat, with center O and radius 3 centimeters, you describe the circle as shown. This is the locus. Now the locus of point equidistant from 2 points. This one is a locus of point equidistant from 2 points. Take note. From 2 points. Equidistant from 2 points. Example. A point P moves in a plane such that its such that it is always equidistant from two fixed points. So these are the two fixed points we are given, A and B, separated by a distance of 6 centimeters. Separated by a distance of 6 centimeters. So if we are searching for the locus of point equidistant from 2 points, from the question we are given the point A and B, that locus we are searching for is the perpendicular bisector of A and B. That is all. Now let's look at what I mean by that. Line AB was given to be 6 centimeters. So when you bisect line AB, we have the distance from A to the line P to be 3 centimeters, and the distance from the line P to B is also 3 centimeters, because you know how to bisect a line. You stand at A, open to more than half the distance, describe an arc above and below. With that same radius, stand at B and describe an arc above and below, and draw a straight line. That will give you the locus. That is the bisection of the line AB. So if you are describing a locus equidistant from two fixed points, it means that bisect the line. That is all. The locus of point equidistant from two given intersecting straight lines. The locus of point equidistant from two given intersecting straight lines. Take note, equidistant from two given intersecting straight lines. If a point P moves in the plane such that it is always equidistant from the intersecting straight lines OA and OB, then the path traced by P is a line bisecting angle AOB. That is all. So OA is a straight line, OB is another straight line. So if you are searching for the locus equidistant from the two intersecting straight lines, then it's a matter of bisecting that angle the two lines make. That is all. So OA is a straight line and OB is a straight line. When we bisect, and we know how to bisect an angle, when we bisect the angle AOB, the line we have is what we call the locus. That is the locus line. That is the locus. Now the locus of point equidistant from 3 points. The locus of point equidistant from 3 points. So a triangle has 3 points. That is 3 vertices. We have A, B, C. How do we construct a locus of point equidistant from 3 points? To construct a locus of point equidistant from 3 points, we need to bisect any two of the lines, either AB and BC, or AB and AC, or AC and CB. Any of the two lines, we bisect any of the two lines. Now let's bisect the line AB. So you stand at A, open to more than half the distance, and describe an arc on the right and on the left of the line AB. So first, when you are bisecting the line AB, you can either start from A and end at B, or you start from B. Now in this case, we stand at B. That is, we are starting from B. So stand at point B with the help of your compass and open to a radius more than half the distance AB, and describe an arc on the right of AB and on the left of AB. With that same radius, stand at point A and describe an arc on the right of line AB and on the left of line AB, also as shown. We now draw a straight line passing through the intersection of the two arcs on the right of AB and on the left of AB, as shown. That's the straight line. So this is a perpendicular bisector of the line AB. Now we are also going to bisect another line. Now we are going to bisect the line AC. And bisecting the line AC, we stand at A with the help of your compass, open to more than half the distance between A and C, and describe an arc on top of the line AC and on the right of the line AC, as shown. With that same radius, stand at point C and describe another arc, as shown. Draw a straight line passing through the intersection of the two arcs, as shown. Where the two lines meet, name it point P. With the help of your compass, stand at point P and open to any of the vertices, either A, B, or C, and describe your circle. You will have a circle that is passing through all the 3 vertices of the triangle. So that is the locus of point equidistant from 3 points. Take note that you bisect any two of the lines. Where the two lines meet, name it point P or any variable you want. You stand at that point, open to any of the vertices and describe your circle. It will be a circle passing through all the vertices of the triangle. Now we consider the locus of point equidistant from 3 intersecting straight lines. The locus of point equidistant from 3 intersecting straight lines. So with the locus of point equidistant from 3 intersecting straight lines, that is line AC, line CB, and line AB. These are 3 lines. If you want to construct the locus of point equidistant from these 3 straight lines, what we do is to bisect any of the 2 angles. It can either be angle C and angle A, or angle A and angle B, or angle B and angle C. So let's see how best we construct the locus of point equidistant from 3 intersecting straight lines. Take note, locus of point equidistant from 3 intersecting straight lines. We can see the straight lines AC, AB, and BC. So we bisect any 2 angles. So we bisect the angle at C and the angle at B. And you know how to bisect an angle. You stand at point C, open to a reasonable radius and describe the arc. Stand at this point, describe this arc. Stand at this point and describe the arc. You draw a line from C passing through the intersection of the arc. That will give you the bisection of the angle at C. And the same thing happens at B. That is, you stand at B, open to a reasonable radius and describe this arc. Stand at this point and describe your arc. Stand at this point and describe your arc. Draw a straight line from B passing through the intersection of this arc. That straight line you drew bisect the angle at B. So we now draw the straight lines as shown. Where the 2 straight lines meet, where the 2 straight lines drawn from C and from B meet, name it P. With the help of your compass, stand at point P and open to the side of the triangle, any of the side. It can be AB, it can be the side BC, or the side CA, and describe your circle and construct your circle. And that is the circle as shown. So when you are constructing the locus of point equidistant from 3 intersecting straight lines, the circle is within. The circle is within the triangle. Take note. That is how we construct the locus of points equidistant from 3 intersecting straight lines. This is the end of our presentation on construction.